This is a quick review of a finless egg rocket that I built. So I built this for Easter. I didn't actually get it to fly on Easter for that launch, but I finally got it to fly yesterday, so I wanted to give a quick review. So the idea is that this is an egg, and the pad I'll talk about in a second spins the rocket to spin stabilize it almost like a rifle bullet.
That's sort of the Cato.
One feature I wanted to show that I found during development is I made a little thing on the end of a paint stick, basically, along with a knob on the top. And what I do is I put that on there to be able to just kind of lightly hold it in place while it comes up to speed. Another thing about the egg itself is I put some features around it. They don't actually all have screws in them, but I used some screws here out of the perimeter to balance it after it was prepped for flight. So the egg, when it launches, it's held fast in sort of this funnel assembly, which again rotates around, and when it launches, it completely separates, and you can see you got pretty scorched. No surprise there. I kind of viewed part of this as disposable, but I think the rocket might fly again. The slots there are the veins that these went in before the motor melted them completely. The egg itself is intentionally very light and simple. It's a pretty big 3D print on the bottom, along with what I call a nose cap. Sorry about that. That holds. So there's the nose piece. It just kind of fits in there with some slots. That was important because of when it was spinning and you're holding it, could cause it to twist. And then I put a little cup in here to try to hold the chute towards the center and also kind of keep it stable. So the cup kind of constrains the chute, so it's kind of force fitted in there. And then what happens is the motor then blows the top assembly off along with the chute cup. The chute comes out. Really long shock cord on this one because I was concerned about the spinning, continuing and it fouling. So that's the entire rocket piece right there. So again, that part's pretty simple since the chute. The spinning piece is a little more complicated. I'll show you a separate test here in a second. I want to get some good pictures of. This is the brush assembly I came in. That was a major change before. So it uses some orthodontic rubber bands there, and 3 stacked washers for each one, so the wires kind of go in the groove with the washers, and then the clamp to hold it. And then this is all mounted on a thrift store find. I think this was in a former life, maybe a piece of survey tool or something like that. The original piece was this, and I bought it for just a few bucks since it didn't have any of the other pieces with it, but it turned out to be a really sturdy tripod that I could use for some experiments. And then this assembly, below the brush assembly, has some bearings in it. So I found that I had to use bearings and some stainless steel rods. I tried a variety of things with sleeve bearings and other things, but it just had too much wobble. So I bit the bullet and did that. Then this piece, which was screwed in for the launch, holds the rotating assembly. So this rotates. Here's where the gear on the motor connects to it. So you just pop that in and be able to put the motor. The motor itself is mounted under this new 3D printed kind of tripod head that I built, and is controlled by that speed controller over here, which I just use electrical cord to be able to connect that to the 12-volt battery that was also powering our launch system. So that's pretty much a run through of it. I'll show you a quick video of a test I did before flight, and then the flight. This is a quick test of the revamped igniter. So the problem I had on the first launch was this brush assembly that I made using just a copper coupling that I cut off a couple tube lengths of. It didn't work. I was thinking that the 3D print would hold the wire in place, and it didn't. So ultimately what happened was the wire went between, kind of rubbed against the 3D print and kind of wedged itself in there. So on this new version, I put in some washer assembly. So same basic idea, a little bit more buttoned up with a little bit more time. So this is gonna be a test. I've just put an igniter in the top. Again, these are brushes so it can spin, and I've hooked it up to two 18650s. You can see on there. I'm not gonna spin it very fast. Now let's give it a go and see. All right, so now I'm going to connect. So the brushes then are stationary here. They go to the washers and then they connect. So hopefully when I touch this, it will fire the igniter. All right. I put extra gunpowder on it, so that's kind of what I did. So I would call that a success.